Hello again everybody and welcome back to episode 4 of Coding with Kenny G, where we're making the Viking Chess Hnefatafl remake game. So, we got quite a bit done last episode, where we got some camera movement by allowing our camera to look at a certain target, and we managed to create the entire board and have a data structure for it that is now in memory that we can connect to and use further. So I was thinking that this episode we can try to get a little bit of simple camera movement and also be able to select a tile. There is a little bit of stuff going into that, so let's just get right on it. So the first thing that I'm going to do is that I want to set up some of our input. We're going to project settings, and then we're going to input manager. We're going to use the old input manager for now. I'll see if I decide to change that later, but I'm so used to this. It's a little bit, I'm more used to it, so setting it up faster. We're gonna use the horizontal and vertical axes to move our camera. The only thing that I'm gonna change is that the buttons that we're gonna press for actually rotating the camera up and down is gonna be on the vertical axis, and I'm gonna use the buttons E and Q for them. That's because in this game you can kind of move towards center tile and from using W and S. You can rotate around the center tile using A and D. And you can rotate up and down using Q and E. For now, I'm just going to implement these two. And we're gonna take the rest of the stuff a little bit later, because I'm just gonna do the quick and dirty right now. So that was in the input manager, and I changed the vertical. That's it. All right, so that's ready to go, and we're gonna talk to the camera controller, and we're gonna move this guy here based on which axis we're pressing down, and we're gonna rotate around the center tile. That's the whole idea anyway. I might change how we do this a little bit later, but as long as we have a looker target, we're allowed to rotate around this point. So now we're going to allow for input. And let's start with the horizontal axis. So the thing that we need to move is our transform. That's why we have the my transform, which is good. So my transform dot rotate around this one takes in a point and an axis, and in this world our game board is not tilted, so we can rotate around the y-axis, because that is the vector 3 dot up, which is the world up. It's completely 90 degrees, and our board is 90 degrees. So we're gonna do that. Vector 3 dot point. About axis passing through point. I think it was like this, that we do a look at target dot position vector 3 dot up with the capital letters, because it's the global up, and then the angle, that's where we modify. So before I finish this one up, I'm gonna have a tweakable here up in the public fields, and we're going to call it public float movement speed equals 60F header tweakables. So fields under this header, if we have more down here, are tweakables until we meet the next header. And tooltip is how fast does how many degrees per second does this transform rotate. I think that will be pretty correct. It's in the middle of the night, so I'm a little bit slow in the brain, but that's fine. It's kind of fun. So yeah. So we have movement speed, and it's assigned a default value. And then here we're gonna do. Whoops! What did? Okay, something exploded. Right. So in the angle part of this function, we're going to write input dot get axis of, and you have to write in string exactly like it is written in the input manager, horizontal times movement speed times time dot delta time. Close it with parentheses. There we go. Let's just see if this works, because I need to remember if I use this function correctly. So now that I press play, and if everything works and I press A and D, yeah, I'm allowed to rotate. For me, this goes the opposite direction. Like when I press D, it moves to the left. I don't like that. So I can just flip the direction here by putting in the negative input. It just means that the directions are flipped. That's a personal preference. So when I press D, or hold D that is, and then I move towards the right, which is what I want. Cool, so we implemented one axis, and let's do the vertical. My transform dot rotate around, look at target dot position, and this one is gonna be the x-axis. So but this also needs to be local. I'll show you what happens if we use the global. So I'm gonna use the global vector3 dot right, and then I'm gonna write input dot get axis vertical times movement speed times time dot delta time. I'm gonna show you what happens when I use the global. I think this is nice to see. Yeah. See that twist? That now I'm trying to rotate up and down. It kind of gets a little bit weird. It's not supposed to be like this. That's because we use the global vector3 dot right. I need to use my local right, which is relative to the forward axis of this particular transform. So we're gonna write my transform dot right. That means it's using its local parameters. I can show you in Unity how that actually looks in the scene view. Camera, where you at? There you go. So I'm just gonna set this up. If you see where the blue arrow is pointing, this is in local coordinates. But if I press global, we're gonna see the global coordinates, which in this case is the straight up pointing arrow. That's the vector 3 dot up, the global. But the local is based on rotation and where it's at in the world. So just to show you, now that I press Q and E to rotate up and down, this works. We're not seeing anything below here because a quad is it's not by default double drawn from both backside and front side. But we don't need to see the underside of this guy anyway, so that's fine. We have an issue though that I'm actually not gonna fix right now because I just want to set this up for now. But we're gonna have to clamp the movement of this so that we're not allowed to go below this rotation and not above a certain rotation. You see now that I'm pressing up against the max, we get artifacts which we do not want. That's because the whole rotation is freaking out. So but we're gonna keep that for now, just because I want to get something else set up that we can start to use, and I think you will find it fun to have things to click on and fairly quickly get an actual game going. So for now I want to be able to select a tile, and that is a little bit of an involved process. It needs a few things to happen. So first of all, how we're actually gonna hit a tile. That is gonna happen through a raycast, which is gonna fire exactly on this blue line here. Or yeah, pretty much, yeah, I guess so. It fires straight out of the camera towards mouse position. And that depends on where our mouse is, but Unity helps us. It's thankfully not something crazy that we have to do to figure out stuff out. So we're gonna fire a ray from the camera into the scene based on mouse position, and pretty much through the mouse position, just in an infinite line. And we're gonna hit a tile, and we're gonna change the color of that tile. But there are a few things that need to happen first. Before we even go into code, we're gonna set up something. And this is gonna happen in the prefab. So we have tiles, and we have quite a lot of them, right? And this particular raycast that we're gonna use, we're only gonna fire towards only tiles. It can't be blocked by any other colliders. This happens through something that is called a layer. And it's up here on the right in the inspector. And we're gonna create a new layer here. So I'm gonna add a layer, and I'm gonna call this tile. The thing is, many people don't catch that it's not assigned once you create it, so you also have to go back and assign. So I need to assign tile to the tile game object. You get a question if you want to change the children, and you say yes, change the children. One of the things that is important here is that the collider, the thing that we're actually hitting, that is on a child object. It's gonna be apparent once we do this in code, because the data of the object is in the parent, but the collider is in the child. We're just gonna see this in action pretty soon. So yeah, tile is now set up to layer tile. Good, both of them. They need to be both of them. This one too. This one, not really, but it helps to think correctly about stuff. It's easier to see what's going on. I just press here and I just, yeah, it's correctly set. All right. Camera controller. So the camera is also gonna try to fire fire rays against a certain layer, and we set that up here. It's actually also tweakable, so we can keep it under tweakables header, and it's called a layer mask. Layer mask. You need to have a we set this up in the inspector, but this is a tile layer mask. So in the camera controller, new public variable, and I'll just write a tooltip for this guy. The layer, the tiles are at which we fire a raycast against to check to allow input on it. Okay. I'll save the script and I'll go back to Unity and I'll select the main camera, and here it says nothing. Well, we are gonna fire against tile, so we select that one. And this is gonna happen in update. Void update. So remember that late update is for handling movement of the camera after everything else in the world has done their updates. Movement, mainly. You can use late update for other stuff, but that's one of the main reasons why late update is late update. But for most other things, use update or fixed update if you're doing physics stuff. Right, so we're gonna check for input in the update. And here we need to set up our raycasting scheme. Blah, 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 blah. Let's go. This is just one of those things that you learn doing it a lot. So I'm just gonna set up a raycast hit. So this one is ready to go. And then we say if physics.raycast, and here, this is one of those things that I don't always remember, but let's see here. It is also one of those functions that has like 10 million different variations. I think that we can get a ray from the camera towards mouse position using my camera. So my camera dot ray screen point to ray. I think this is it. We can debug it. We can actually debug it before we even do something. Ray tile ray equals my camera dot screen point ray. Yeah, and then we push in input the mouse position. There we go. Debug dot draw ray from mic transform dot position and tile ray dot direction times 1000. And also maybe a color I think we can add to this. Yeah, color dot red. Let's just check if I'm thinking correctly here. So then we need to have the scene view open and we need to find the camera. There we go. And we'll just see if it fires a ray. So yeah, this one is firing correctly. As you can see, it fires a ray also through everything. But that we're gonna solve in the raycasting function. So we can just use this variable, and we do the check if against what we're actually hitting here. So if physics.raycast, and then we need to find a function that has everything that we need. Yeah, I think this one looks good. And we send in the tile ray, since it is a ray. And this is just how you have to do it. So you write out hit, because we wrote that unassigned variable there. And we're just gonna fire like 1,000. That's a very long ray. It's infinite pretty much. And then we're gonna send in the tile layer mask. Tile layer mask. Boom. You see that this is actually when we it asks for an int, and this one doesn't look like an int, but Unity does some magic stuff behind the scenes to make this into an int. So if you aren't familiar, don't worry about it. Just send in a tile layer mask and you'll be fine. As long as you set it up correctly in the inspector. And now this ray that is fired is only gonna try to interact with tiles. And I can show you. So every time we hit the tile, we just say yay. And we're gonna start from the outside, look at the console here, and then it's gonna stop once I aim outside of this, which means it is working. Cool. So here we're gonna get a little bit more code heavy. We're gonna change the color of a hovered tile. We're gonna think about it like this. A hover tile is not a hovered tile. It's not clicked yet, but we want to show the player that you are now doing your input correctly by aiming at a tile. First of all. Later we're gonna have to modify this more, but for now we're gonna set up a color, public color, and we call this hover tile color, and we can default it to color.cyan. Unity brings some default colors if you just use the big letter color structure. Let's tooltip it. The color tile changes to if it is hovered. Yeah, we're gonna fix issues as they come up, but we're just gonna start by being able to paint the entire thing. So we need to have a reference to the current hover tile. Current hovered tile. I speak a little bit slurry in certain words sometimes. Private tile current hovered tile. So before we even sign to this, we can paint the entire canvas if you like. Maybe make a completely different game, a drawing game. You can do this by because I'm gonna show you how you interact with what you're actually hitting. We know that the object we're hitting is at least on tile layer, which we have assigned to the tile prefab object. Therefore, we know that a tile has certain components on them because we have made this game so far, right? So we're gonna get a reference to the tile that we hit. So tile t equals hit dot get hit dot collider dot get component, and here's the thing I talked about earlier. We know that the collider we hit was in the child object of tile, but we want to talk to the component tile which is in the parent. So we need to get the component in parent of tile. Then we have a reference to the tile that we hit, and we can change that color. So t.myRenderer, which was a little bit skanky way to do it, but it works. Material.color. Yeah. Now we're just gonna change the property. So t.myRenderer material.color equals hover tile color. Hover tile. Okay. We're gonna go back to Unity and then we can paint the entire thing. Because for now we don't have a function that resets it back to what it was. So this is where we need to let a tile know a little bit about its own default state, which we are going to set up in tile. So we're gonna have some private fields here, which is its initial color, or the color that is assigned to this material when this guy gets instantiated. So private color get start color. Okay, and we're gonna assign to that in awake. Notice that I'm always putting these functions and stuff into its brackets in these regions. I hope it helps you. Once you see that, it's kind of useful. Private void awake. We're gonna assign start color equals to myRenderer dot material dot color. So then that is assigned, and then we're gonna have a getter for it. We should avoid talking directly to variables. It gets very, very greasy very fast, so you don't want to do that. Even though it takes a little bit more code and blah 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 blah, especially for certain things, it's definitely worth it to do this a little bit of a long haul. So we're just gonna create a helper function. So get start color that other guys can call on, and then we return start color. That's it. So in the camera controller, where we're now assigning colors to this guy, we need to assign a variable of who are we currently hovering, and if we are not hovering that guy anymore but hovering something else, we need to change and reset the state of the color. So first of all, I'm just gonna delete these two lines that I wrote there, and I'm gonna first of all I'm going to check if I have if current hover tile is null. If it is null, then this is the first thing that we're hitting. This is the first tile we're hitting. Then current hover tile equals hit.collider.get component in parent of type tile. And we're gonna assign that the hover tile color. So current hover tile dot my render dot material dot color equals hover tile color. All right. So at this point, is there a current hovered tile assigned, but hit dot collider dot but hit dot, let's write it like this, dot tile is another tile than the one we're saved. Then we need to we need to reset the current hover tile back to the start color, and then we're gonna have to reassign current hover tile to the new guy. So if hit dot collider, there is a more efficient way of doing this. Okay, I'm gonna do the inefficient way first, and we're gonna clean it up a little bit later, because I need to think a little bit on how to do this more efficiently. But if hit.collider.get component, which is bad, in parent of tile, yeah, so first, before we write this, if current hover tile is not equal to null and hit collider dot get component in parent tile is not equal to current hover tile, we are hovering a new tile. Reset old, assign new. So the current hover tile isn't changed yet, so we say current hover tile dot my renderer dot material dot color equals current hover tile dot get start color, the function that we wrote as a public getter function in tile. So we reset that guy. Now assign new tile and color to new tile. So current hover tile equals hit dot collider dot get. You see what I mean? It's not beautiful code. This it won't give us too much hassle though, but yeah, it's ideal to always try to make things faster if you can. Okay, and then we update the color here. My render dot material dot color equals hover tile color. There we go. Ooh. So I see that we're turning all the colors into white. Let me just check. So this is a little bit of debugging, that's fine. Get start color. So what do we have when let's just make this public real fast, just to debug in tile. Press play. So this guy is white, yeah. Somehow the renderer has not been updated yet. Interesting. Okay, I'm gonna move this to start. Boom. Yeah, it was an issue where when this previously it said awake here. I was a little bit surprised by this actually, but okay. The thing that is happening is that my renderer.material.color had not been assigned yet at the point that this guy was instantiated. That's because we are assigning the color from the materials after we instantiate the guy. So it needed to run in the start function, because that is a little bit, it's not slow, but it's a little bit after everything. And that's why this works. Interesting. Okay. So then, after fixing that, we should see that we are now able to hover tiles and change into a new target, right? There is one little thing, I can aim outside and this guy is kind of still selected. I want to avoid that. So if at any point in our camera controller, if as a outside the raycast, we check if there is a hovered tile, but we're not hitting anything inside the raycast, reset the current hovered tile to start color and deassign the variable to null. So we just check if current hovered tile is not equal to null outside, then current hovered tile dot my renderer dot material dot color equals current hover tile dot get start color, and then we say current hover tile equals null. So it's ready to be reassigned inside here. So once we play, we should now be able to aim outside of the board. Woo! Yeah, I did a little mistake, it seems. Okay, I need to probably think a little bit on it then. I'm just going to delete this for now and see what I did there. At least it's not completely game breaking to have it like this. So, alright, I think that we're gonna leave the episode for there. So we got some input, and soon we are able to click a tile and do actions on it, which means that soon we can start. I'm gonna create a little system where we can place out these, I call them actors, or game pieces, out onto the board using a so-called formation creator, which is pretty much like a little level design tool, where you can create different formations and save them. But that is a little bit more into it. But I hope you would look forward to that, and I'll see you in the next one.